In this video, we will learn about C data types, variables, and Ascii. So let's start by creating a new file and we will call it 05 underscore data type .c. You can name the file anything, but the file name has to end with a .c extension. And here I will mention the things that we will be learning. So the first thing that we will be learning is data types. There are different data types that we have in C. And second thing that we will learn is variables. And third thing that we will learn is ASCII or ASCII table. Now there are different types of information and we have to tell C what type of information are we storing with data type. And variable is what stores the information. Think of it as a container that has a label with information. So you can think of it that if you wanted to store information, what we would have is we would have the data type, which would, let's just say, would go here, and then we would have the variable name, and then we would have the information. This is how we would pretty much format the whenever we try to store any information. Now we can either just store the information just like this, or another thing that we can do is we can just have the data type and we can also have the variable name, but we can tell C that hey, we will just save the information afterwards in the future, but for now just do this. So now let's look at what these data types are, and we will start by typing include stdio.h, and we will include the standard input output library, and we will have the int main void. Now char is one of the data types. Now char can store one character information, and we can have one single alphabetical character, and we can store ABC, or we can store 1 2 3. And in order for us to store information in a char, what we need to do is we need to have a single quotation marks and then a single character. That's how we would store information in a char. Now another data type that we have is it's called an int. And int, you can think of it as an integer, and the int data type we would store numbers, and we can have, let's just say, 1 2 3 9 8 7 and negative 6 7 8. So these are the, and we will store numerical data in an int data type. Now what we will do is we will store some information in a char data type, and we will have the char, which is the data type right here, and char underscore a, this will be the name of our variable, and this right here will be the piece of information which is a. And I will have another line, char underscore capital A, and then I will have the single quotation marks and then a, and then I will have the semicolon at the end, and then I will have the printf. And in order for us to print a character information, what we have to do is we have to type the percentage sign and then C, and then we will have a comma after outside, and then we will have char underscore a, and this will print a lower a character, and then we will do the same thing. We will do printf, and then we will have percentage C, and then we will have a comma, and then we will have char underscore capital A. Now I will comment this portion out because otherwise the compiler will just give us a lot of error and warning messages. And now we will compile this. And now when we type this, we can see that we have the a, lowercase a, and the uppercase a. Now if you are wondering that why is it that it just printed everything in the same line, it's because we have to tell C if we want to see these in two separate lines. So in order for us to do that, what we would have to do is we would have to type \n in the first line and then \n in the second line at the end. And now when we compile this again, And when we print this, now we can see that we have lowercase a and an uppercase a. And this is the first way we would store information in a char data type. Another way we can store information in a char data type is, instead of having all three, the data type, variable name, and information all in one line, another thing that we can do is we can have the data type, which is char, and then we can have the variable name, which is char underscore a, and then we will just finish that line off with a semicolon at the end. And I will do the same thing for the second line, char and then char underscore a. And here now what we will do is we will do char underscore a, and then we will have an equal sign, and here we will just type a, and here we can do capital A and then have the equal sign, and then we will have the capital A. We will save this, and this we will just leave this as is. And now when we compile this and print, and we can see that we get the same information. And that's just another way of storing information, and it really depends on you. If you prefer to store information just like this all in one go, you can do that, or if you want to do this, you can also do that. And what we are doing when we do char underscore a equals single quotation marks a, what we are doing is we are storing the value of this single quotation a into char a, and we are storing the single quotation capital A value of this inside char underscore capital A. And whenever we want to get the values of these right here, what we would have to do is we would have to enter char underscore a, which is this right here, so we can get access to this value. And then we would have to type char underscore capital A, which is this right here, so we can get access to capital A. And now what we will do is we will store int data type information. And in order to do that, we will have int, and let's just call it num1. And here we can type this number. And for num2, we can do -456,123. And here what we will do is we will change this printf from %d to %c to %d, and we will change this from to num1, and this we will change it to num2. And we will compile this, and we can see that we have the number 789,456 and 456,123. So that's how we would store integer or numerical values, and this is how we would print this with a %t sign. So we stored the information of a char data type, and then we printed it with %c, and then we stored the int data type information, and then we printed that with the %t sign. Now what we will do is I will show you another thing. Let's just say that we have the char data type again, and the variable is called char underscore a, and we will store the lowercase a, and then we will have char underscore b, and then we will store this, and we will store lowercase b. Now we will print their values, and we will have char underscore a, and here you can see that it says a use of undeclared identifier char b, and it tells us on what line, which is 48. And when we come right here, this variable, it says that it's undeclared, and that's because I misspelled char. So now when we save this, so now we have the a and b that gets printed. Now watch what happens when I change this from C to D. So this is what it prints right now. And when we save this and compile and run the program again, now instead of printing A and B, it prints 97 and 98. And that's because if you type man and then ASCII and press enter, and if you come all the way down, you will see that on this ASCII, and we call this ASCII table, you will see that 97, A has a value of 97 and B has a value of 98. So when we have the percentage %c, what this would do is it would just print the character, whatever that character is. But when we do percentage %d, what that will do is it will give us the numerical value of what that character is. And if you were to do uppercase A and uppercase B, now what it will do is it will print 65 and 66. And that's because we have, because A has a, on the ASCII table, A has a numerical value of 65 and B has a numerical value of 66. Now if we change, so that's one thing. Now what I will do is I will comment this out. And now what I will do is I will copy this pretty much all this portion and I will bring this down here. But instead of having char, what I will do is that's the only thing that I will change. I will change this to int, and I will also change this to int. And I will run this now. And when we run this, we can see that int can also store character information. And this is also able to print the same information that char was able to print. And now if we do the same thing, and if we do C instead of %d, what this will do is int will also be able to print A and B. And just like how we were able to store the alphabetical value of a character inside an int, we can do the same thing and we can store a numerical value inside a char. And I will copy this chunk right here and I will bring it down. And what I will do is I will change this from int to char, and this portion right here I will also change this from int to char. And here instead of writing having B, I will change this to 66, and here I will change this to 65, and I will leave this as %c and %c. So 65 right now on the ASCII table is the uppercase A and 66 is the uppercase B. So when we compile and run this now, we will see that it will print A and B. And if we change the C to D, it will be able to print the numerical value of A and B, which will be 65 and 66. Now char cannot support as big of a range as an integer data type can. So let's just say that if here we had -129 and here we have 128, and if we try to print this, and when we compile this for line 61, it says that implicit conversion from int to char changes values from -129 to 127. So here what's happening is it's called underflow, and what's happening is that the value when we print this, that the value -129 is getting changed to 127, and on line 62 when we have 128, that's getting changed because what's happening is called the overflow, and 128 becomes -128. So just know that if you want to store a numerical value inside a char, then that values range would have to be between -128 and +127. I just wanted to show that how we can store information interchangeably between char and int, but if this became too confusing and if you just want to keep things simple, then what you can do is you can use a char data type to store character information, and then you can use %c to print that character information, And you can use the int data type to store numerical value or the integer value, and then you can use the percentage %d to print that value. Now the next data type that we will look at is called bool, which stands for boolean, and boolean prints true and false. And in order for us to access the bool data type, what we would have to do is we would have to include the stdbool.h library, and we will do include stdbool.h, and we will come all the way down here. And now let's just say that we have a variable called var underscore one, and we call it true, and we have a second variable called variable 2, and we will set this equal to false. And now when we print var1, what this will do is it will print 1. And when we print var2, what this will do is it will print 0. So I will compile the program, and as you can see that when we have the value of a bool data type set equal to true, what that will do is it will print 1. And when we set it equal to 0, or when we set it equal to false, what that will do is it will print false. And instead of typing true and false explicitly, what we can also do is we can also just have 1 and 0, and these would also mean the same thing, that when a bool data type is set equal to 1, that what that means is it's true, and when it's set equal to 0, what that means is it's false. Now the next data type that we will look at is it's called a float. So we will type float, and let's just call the variable num1, and we will store 45.5. And in order for us to print the value of a floating variable, what we have to do is we have to type %f, and then we will have num1. And you can see that we have 45.5. Now if we try to do the same thing with an int data type, what will happen is that it will just drop the 0.5. And what I will do is I will come down in a new line, and I will do num2 equals 45.5 and printf and %t, a new line, and num2. And the first thing it does is it gives us this warning, and it says that implicit conversion from double to int changes value from 45.5 to 45. And we can still go ahead and print this, and it will be fine. And it prints the value, but what it will do is it will drop the 0.5, just like how it said in the warning. So the float data type allows us to have a decimal value, but what the integer data type will do is it can only store and print whole numbers. Next data type that we will look at is called double, and double stores decimal values just like how float does. And we will type double num1 equals 45.5, and in order for us to print this value, we will use %f just like how we did for floats. And then we will have the new line, and then we will type num1, and when we compile and run this, we can see that we have 45.5, and then we have a lot of zeros after. Where float and the double are similar is that both float and double allow us to store decimal values, and we can also then print the decimal values. But where they are different is that float takes pretty much half the space of the double data type, and double data type has a much bigger range than the float data type does, which is also the reason why double data type takes twice the space of a floating data type. There are a lot more data types, but char, int, and float will create that foundation for you to understand other data types. In the next video, I will talk more about some other data type that are known as unsigned.